All right, let's see. So I'm Brad Burris. I'm here from Intel, where I'm a senior principal engineer. I have been driving our SoC and NIC architecture. So I'm really excited to come here today. Thankful for the opportunity to come and talk about the new NIC 3.0 specification. We really think this has been a great collaboration across the community. And we hope that this new definition will really drive a lot of change and adoption into the market. Okay, so where we're at today, NIC 3.0 spec is really getting near completion. We'll see the 1.0 version of the spec by the end of the year. Today, we're right at the 0.85 definition. And what that really means is that it's a usable definition today. So you can go off, you can download the spec from the web, you could build a fully OCP3 compliant NIC card. And if you've been through the expo today, or as you can see we have here, there's real designs built and working today using this new specification. This effort has really been a strong community design where we've gotten more than a dozen partners to think about what the specification needs to apply their own insights and to really work together to come up with something that will satisfy cloud and all the other data center use models for the immediate and foreseeable future. And we've kind of, by integrating all those requirements together, we think we've got a spec that can really add value for both the hardware vendors, for the OEMs, and for the end users. So if we just do a little walk through history, where did we start? We started with Facebook coming out in 2012, creating the 0.5 version of the spec. This was really sort of focused in on a narrow use model for a NIC. It was really sort of a simple design point, getting 10 gig Ethernet, dual port with enough bandwidth to satisfy that by 8 Gen 3s, and a relatively simple I2C management interface to the NIC. So this was good for a start, but it was really kind of targeted at a particular use model. And this was sort of realized as a narrow scope. So Facebook took the initiative to drive sort of the Gen 2 version, where we really worked towards extending the specification, supporting a much bigger set of speeds and feeds, supporting all the way up to 100 gig Ethernet, supporting a larger distribution of port counts and port combinations, and obviously increasing the bandwidth up to the server so that you can feed the wire. The other big thing that 2.0 did is it did a really good job of extending the manageability interface to something that was much more standard across the industry so that a lot more people could get behind it. So with that 2.0 change, we really got a lot more adoption. We saw more CSPs using it, we saw more hardware vendors supporting it, and really saw the NIC standard within OCP starting to take off. So that was really good. Unfortunately, there was some challenges with NIC 2.0. It had some challenges in terms of having, just because you designed a NIC 2.0 card didn't necessarily mean it would plug into an OCP2 chassis. There were some mechanical challenges. There was a few too many options around what connectors you could use. Also had some challenges on serviceability in terms of, if you wanted to get out and replace the NIC, you'd have to open the chassis and remove some things to do some work. So there's definitely some things we saw with the 2.0 spec that we really wanted to work on. And this is really what 3.0 has done. So starting in 2017, with Facebook, again, driving and really helping to lead, we got the group of the whole ecosystem together and really tried to tackle all of those things that we saw that weren't ideal in NIC 2.0 spec. As well as the thing we tried to do with the 3.0 spec is work towards be a little more forward-looking. Think about what are the changes we can put into the spec now to make us ready for the future. Things like being PCI Gen 5 compliant, things like plumbing more bandwidth to the server. So that's where we are today. And it really has been a community effort. So I think you may have seen Jason Waxman's presentation at the keynote, right? We've talked about the fact there was 14 partners that were working on defining the spec. It's really been a long process with a 2-year development phase. We've gotten with Facebook leading, Intel's been a big contributor. We've helped to drive the spec, working on some of the pinouts, things like that. We had a lot of work from Dell, from Broadcom, from Marvell, Mellanox. So there's been a lot of partners working on this. Each company brought their own set of unique requirements, and so this is what the benefit of being open is that together, all of the subgroup work together to figure out what's the right feature set, what's the right goals, and how do we put it into a spec that's going to be easy to follow, easy to build, and ultimately give us products that will last for a long time. And so, it's been a great partnership, and where we've gotten to, and starting from 2017, is real products being launched and available that you can go see in the expo today. So if you dive into the meat of what we actually took on with the 3.0 spec, it's sort of what I said before, right? We focused on making the design easier, right? The mechanicals are easier. You're going to be guaranteed that if you build a NIC to the standard, it's going to fit in the chassis. Obviously, something you want as a hardware vendor. It's much more serviceable. So rather than having to open your chassis and pull things out and get to the NIC underneath, you now can simply walk in, pop it out, pop it in. You're done in seconds, right? As opposed to minutes. That's a huge enablement for the operators. We thought through the power and cooling more thoroughly this time, right? So we've got a new thermal management solution coming on board. One big thing is we've really focused on understanding sort of the power and cooling requirements, whether you're in the hot aisle or the cold aisle. That's thought through and specified in the spec. We've also thought through some of the new changes which may drive higher power requirements. So the spec contemplates, burning much more power into this NIC 3.0 card. So all of that's kind of accounted for in the specification. And we've identified two form factors. So we understand there's a diversity of workloads and a diversity of goals. And so the NIC 3.0 spec defines a small form factor, really targeting kind of the much more traditional, simple, straightforward NIC. And then we have a larger form factor that's going to allow for scalability to add more things down in there. We'll talk about that a little bit. Manageability-wise, again, this is obviously as an operator, this is one of the things you care the most about in your NIC. So we've maintained the NCSI over RMII interface as the primary path to the BMC, also supporting MCTP over both SMBus and PCIe. And in the NIC 3.0, it does one thing that's great, which is it starts adding this thermal reporting capability, which, again, makes it much easier for the operators to understand what's going on and how to actually get the right information out. And the final thing we've looked at is, again, being forward-looking, being a little more flexible, supporting things like multi-host stuff and bifurcation of multi-host, meaning I could have a single NIC servicing 4 servers off the same card. So have the ability to bifurcate my PCI and share that across the servers, getting the greater densities in the servers, have the flexibility of going up to PCI Gen 5 when it's out, right? So forward-looking in that regard. Okay, so all of those things together, what does that mean, right? What it means is we have an opportunity. And our opportunity here is to from Intel's perspective, right, as a hardware vendor, we have our PCIe card, we had the NIC 2.0 card, we have a bunch of custom cards that we have to make for various different use models and deployments. And so our hope, and what the hope of the subgroup here is that by really thinking through the problem space, by really thinking through what is necessary, our hope is that this really becomes a de facto standard going forward, and that we get a wide adoption of this this NIC 3.0 spec for building cards, and get a lot more people moving to the OCP platform. And the reason we think we can be successful there is, we took into account all of the input from the community, we made sure it met all the hardware vendors, all the OEMs, and all the customer requirements. We did a little forward-looking thing, so as soon as the next thing comes, we're not already at the next cliff, and we've thought through that install and deployment model. From a hardware vendor perspective, as I mentioned, I work on the silicon side at Intel, building the chips that would go onto this. This is exciting for me, right? This by having a much more stable platform to go into and things to think about, it lets us get our products out to market and to our customers sooner. And one thing that's great about this is it opens up a lot of degrees of freedom for us to play in. So like we're looking at, we talked about multi-host, we've talked about having room for more things down in the card, so I can put more chips, I can put more memory, I can do a bunch of things there for giving me the freedom for that. One thing we're really excited about, again, as I think Jason alluded to earlier, Intel announced this week the Compute Express link. This is the link that allows effectively the CPU coherent bus to come across PCIe electricals and interoperate with an accelerator down through the PCIe interface. And so, this will work right on top of the NIC 3.0 spec as is. So if you can come up with a reason to make your NIC, have coherence, have memory down there, there's a bunch of new cases you can do that will just work within this platform. So that's really exciting for us. And we think that leads to end customer benefits, right? If we have more vendors designing to a certain spec, you have more choice. By thinking through how to use it, it should be easier to use, easier to get your value out of it, easier to service. And by solidifying some of the definition, you get to the point where now any card you get is going to mechanically work with your chassis, which is exactly what you want when you buy a card. Taking a closer look at the two form factors. They're intelligently called small and large, where what we've gotten to is really that small form factor, really targeting the much more traditional deployments, the NICs you're using today probably. Typically on the lower end power side, although the spec allows for the power to scale up pretty high even in that small form factor if you can cool it. And this is really, using a standard PCIe by 16 with sort of the OCP sideband wires integrated into that single connector. And then we have the large form factor. This is really the one that's more forward-looking, saying, hey, I might want to put an FPGA down for my NIC. And that's going to be big, or that's going to be hotter, that's going to need more VRs, I'm going to need more board real estate to get to it. Or I might want to put down the new Smart NIC thing, where I have my ASIC pipeline, but I also have a bunch of cores down there, and I'm going to implement my OVS FastPath in software on those cores. And these things are great, and these are things that are trying to happen in the industry, but we didn't have a board in the OCP specification that would let us support that model. And so with NIC 3.0, we do. And this is the way some of the top tier cloud is going today, and is likely a way that we'll see more people want to follow. And so having it into the spec so that we can grow into that with a kind of a robust, thoughtful manner is really ideal. And as we said, the 0.85 spec is out there and is solid enough to design to. And from Intel's perspective, we're super excited about this definition. On the 2.0 side, we had a couple of cards that we had designed. But as we move into the 3.0 space, Intel's going in on it big, right? We put all of our existing parts into it. We have our 1 and 10 gig solutions and designs already. You can see out on the expo floor. We also have our next gen card that's going to be coming out, I think, in Q3. But you can go out and see it in the expo as well, getting to our 25, 50, and 100 gig solutions. And so we really like the flexibility that it gives us, the ability to do all the port configurations we want. So really happy with the way the spec turned out, and excited to design that, and even some other things we have coming down the road as well. So what does it mean ultimately, the 3.0 spec? From our perspective, it's transformational. We're hoping that we've got all the features thought through. We took enough input from the industry that we can really get this broad adoption and make it kind of the new de facto standard. We had PCIe as sort of the desktop standard. Let's make the OCP 3.0 the cloud standard. Let's make that the thing that everyone's designing to, that sets the bar for what are the features that you want to provide in a NIC. We believe that the 3.0 spec really addresses and fixes all of the things we identified with 2.0. We mentioned the serviceability. We mentioned, I mentioned the mechanical compatibility. There's some issues that we fixed around board real estate and being able to actually get to the port configurations you might want. So all of that has been fixed. It's also thought through what do we need to do in terms of supporting future use cases. We mentioned CXL, we mentioned PCI Gen 5, mentioned ASIC-based or FPGA-based smart NICs, things like that. So much more thoughtful about what you might want to do a year out, 2 years out, 3 years out. And all of that together really provides that value for the hardware vendor, value for the end user, and ultimately value to everyone in the whole ecosystem. So hopefully you guys are excited about this as the NIC 3.0 subgroup team is as well. There's obviously, we'd love to get you guys more involved, love to teach you what's going on here. Invite you to come out to the Intel booth or to any of the other subgroup booths that, as you saw on the previous slide. Everyone will be excited to talk to you about it. The OCP Experience Lab, the NIC 3.0 team has a nice display there. I highly recommend you go out and look at what the actual cards look like, what the chassis look like. And the OCP NIC subgroup website obviously has the spec on it. Definitely worth a read. It's really easy to get to, really digestible. Nice place to kind of get a feel for what's going on. And with that, that's all I have. All right. I don't know if I'm supposed to do questions or if we just move on to the next person. So the small goes up to, can go up to, the spec provisions for up to, sure, the question was effectively what are the power envelopes? And you guys might have to help me with this, but the small goes up to 80 watts, and theoretically, right, I think obviously we have some cooling issues around that, and the large goes up to, what's it, 150? Yeah, 150 watts for the large one. I think the more common use model we've been thinking is you're going to be in the sort of sub 25, the likely scenario is sub 25 watts on the small, and the sub 80 on the large is what is a more likely, easily cooled model.
So for the small, is that just powered off of PCI Express?
Yes. Any other questions? Sorry, say that again? Hot swap? Hot swap is supported.
However, the platform has to support it.
The platform obviously has to support it. Right, which is an optional, you're saying, right? Yeah, so it's an optional feature of the platform. The NIC 3.0 spec allows you, obviously supports doing that if the chassis supports it. Yes, sir. So the question was, if this becomes a big standard, is this going to be the only offering, say, someone like Intel is going to have? I mean, no, right? Intel is going to make the products that our customers are demanding. So we'll continue to have, a PCIe form factor, for instance. But what we've had in past generations is a lot of custom ones, not just PCI and OCP, but other ones depending on different chassis we were going into. And so our hope is that the community adopts a much more standard approach around OCP and the OCP NIC 3.0. So we'll do what our customers demand, but we believe that the OCP 3.0 spec should help to land on a single definition, or on much fewer definitions. Yes, sir? Oh. I'm sorry, say it one more time. So it was sort of as we looked through the committee, as the committee worked through it, it was obviously focused on NIC, but there's no restrictions around using the same form factor for some accelerator kind of module, something you want to use it for, right? It's, if you can fit within the power, the thermals, the connectivity you have, absolutely, it's a good spec to start from to go build something. I'm sorry, you had a question up here.
Yeah, is the mechanism for communicating the bifurcation mode, is that standardized?
The pinout and the controls for the bifurcation is standardized in the spec. I think if the question is around how is the software going to configure it from the BIOS perspective, I think that's some of the details that are going to be worked out between 0.85 and 1.0. Yes, sir. Is there, all of the controls are going through those, the two connectors we describe here. So there, we have these two connector types, the 4C plus and the 4C. So what the 4C plus is it's really kind of the PCIe by 16 plus some OCP sideband signals. So it's all part of that single connector.
2.0 has the NCSI sideband, right? That is a PPG.
That's right. So NCSI sideband is running through that sidecar in the 4C plus. Oh, I think I'm getting the hook. So thank you guys very much. I really appreciate it, and enjoy the rest of your day.